Hello, can you hear me now? Anything? Is it working now? Yeah, it's working. All right. All right. So I was asked to take over this Droid programming or Arduino basic sort of introduction programming course. I think the easiest to do is probably use the wokwi.com simulator, so you guys can see at the same time as we follow along, and we can plug in some emulated electronics. So if we go to wokwi.com, you can simulate an Arduino ESP32 or other microcontrollers in a simple fashion. We can go down here and start an empty project. You can go full screen. So here you have a basic Arduino Uno, which is probably what most people will use for a lot of their electronics, even though it might not be in this format. They'll use the chip. Arduino means two things. It means the hardware, but there's also the library. So for ESP32, for example, it can also run with the Arduino libraries, or the Teensy can run with the Arduino libraries, or the Pico, the microcontrollers. But the original one here is the Uno. And so if you start the ID and you're starting a new project, say we want to control an LED, a simple way to do that in the simulator to try it, because we can't blow anything up too much in here. We can add a new part here. Show it again. Select an LED, for example. There are other options here later. Then we can simply connect it. You have the anode and the cathode, and you're going to have to connect ground. And we're going to connect it to, say, one of the pins here, digital pin 3, for example. Oops. Now, in the real world, you would also want to add a resistor in line, otherwise you'll burn out your LED. But in the simulator, we can keep it a little simpler. Now it's connected, but it still won't do anything. You know, there's nothing. If you run this, it won't do anything. We're going to have to enable this pin. So the first thing we could do is say digital write, which is going to write to pin, and we selected pin 3, so we can set pin 3, and we're going to set that to true. We can say true, or 1. It's the same thing. If we run this, it's still not going to do anything. Oh, no, never mind. It's set to output. Yeah, but often you'll have to set the output mode, but set it to output. So let's try that again. It's possibly because of the resistor missing, but that's not very exciting. It just turns it on. You might as well have connected it straight to the power line. So we're going to add a state, and a state is a variable that we're going to use to turn on and off, right? And so set a variable here, say auto toggle, and set it to false. And in here we can simply move our digital write from the. There are two routines. There's the setup routine and there's the loop routine. Setup routine is called on startup, and it's only called once unless your board crashes, in which case it's called again. And then there's the loop, which is called through multiple times. So you're actually supposed to leave the loop routine, and it's going to get called back again. So now we can set digital right here, and instead of saying true, we're going to say the value of toggle. But that's still going to be either false or true, depending on what the variable we set in the beginning. So we're going to change the state of toggle. We'll do it the long way first. So if the variable toggle is equal to true, then we're going to set it to false. If it's not, otherwise, we're going to set it to true. So if it's false, we're going to set it to true. If it's true, we're going to set it to false. Now there's a shorter way to write this, but we're going to start with a long way first. Now this would rapidly blink. Maybe we can sort of try it. It might not even see it. It just looks like it's constantly on. You can't tell the difference. So we're going to add a delay. You can say delay, and we say in milliseconds, we're going to say the equivalent of 1 second. So now if we run it, it goes on and off every second. Now it's not super exciting. We can make this a little bit more compact, and by using the binary operator, where you say toggle is not equal to toggle. So then it get rid of this. You're flipping toggle on and off, and it's going to be the same. Oops, if I spelled it correctly. Now, say we wanted to, we're happy with our little blinking light, we're going to add a servo. Now, there are different ways of doing this. You can use Maestro, you can use additional libraries, but most of the original Droid sketches use a library called servo. First, we'll add the servo, and then we'll go to the libraries. So here we have a servo. We'll put a servo here. And in this, we have to import a library here. So this, we'll go to the library manager. We click on here, and we say servo. And that's going to be down here somewhere. Here's servo. And go back to our sketch. And we say, I think it was servo, my servo. We have to attach it. So we say attach. Okay, I'm skipping ahead here. We'll go back here. We actually have to attach the pins first. So we run the ground wire to the ground. We'll run the power a little bit further down here onto the 5-volt rail. For, oops. You know, for testing, it's usually okay to connect one servo to the 5-volt rail on an Arduino. If you have more than that, it's not really going to work. It may not always work depending on the servo that you're using. But here we're going to make this here red, and then we have the PWM pin. So for most of these wiring, you'll have the voltage and you have the ground, and they both have to be closed. It has to be a closed circuit for it to work. But the third pin is the signal pin, PWM, which is the pulse pin. So we'll say we put him on pin 4. Then we have to go back into the code. We have to say attach. In the setup, we'll have to say attach, and we say 4. See if we got all the spelling right. It has to import the project. It's not called servo. What was it called again? There. We'll go to one of the sample projects. I'm misremembering what it's called. Here's it's called. Oh yeah. Even though we imported the library manager, we also have to include the servo library here. All right, so the servo does nothing. It went to a neutral position, but that's just the simulator doing it. But what we can do now is that here we can say my servo and write to it. Say 180. And this will change the position of the servo. However, it's always going to change it to the same position. So this was just checking that we get everything right. So it moves to the 180-degree position. Now, for servos, there's usually two styles of doing it. One is degrees and one is in microseconds, which is just the pulse value. So you'll see numbers that are like in the RC controller between 800 and 2500. Then that's the microsecond version. But in the servo library, they use degrees for the most part. So now here we can, we can put another if statement here. So if toggle if this toggle state is true, we're going to write 180 degrees. If toggle state is false, we're going to write 0. And we're going to run it. And now the servo will alternate back and forth every second. And then let's go ahead and add, say, a neopixel. Adafruit. Oh. It's in here somewhere. No, it's just this one here. Okay. So here you'll have 4 pins on a neopixel ring. You'll have the ground, which we can connect down here. You have the voltage, which will also connect to the 5-volt rail. And you'll have a data in and a data out. In this case, we'll just use the data in, but the data out it will be used if you'll be daisy chaining multiple rings. And the way the numbering scheme works then is that there's neopixel 0 all the way up to 16 here. And if you had a second one, it would start at 16, the number. The first ring would be, the first LED would be 16. So we're going to connect that to, say, 13. Now we'll have to import the neopixel library. So you type in Adafruit neopixel. And we're going to have to go back to the sketch, and we're going to have to import that as well. Include Adafruit neopixel here. Now, in the ID, if you're in the, it has a tab that says examples. And that's often a good starting point. But another thing you can also do is if you're, almost all these libraries exist on GitHub. So you can just go into the search engine, say GitHub, Adafruit neopixel, and go into examples and say, for example, simple. So what we need is this line here. So this is going to set up our neopixels. Now, we've been using numbers so far, and that gets really clunky and isn't very easy to maintain. So it's good to create a set of constants at the top of your file, and there are different ways to do it. One way to do it is use const express auto and say, for example, num pixels is equal to 16. You'll also see something that says define, which is will look like this. You'll see const int num pixels. There are different ways to do it. I prefer to use something like auto and const expression. None of them is any righter than the other one. It's just a question of what you prefer. Now this has a pin number. We had given a pin. We had assigned it to pin 13. So we'll have to say const express auto. We'll call it neopin is equal to 13. And then we can just copy and paste that down here. So these two constants are defined by the Adafruit neopixel library. We don't have to worry about them. We also have the servos, so we can add a const expression auto, say LED pin is equal to 3, and const express auto servo pin is 4. Should put the semicolon here. And then we can replace these magic numbers in the code with these constants. And the benefit of doing it this way is, one, it will become a little bit apparent in a little bit. It's more easy to assign it to if you're moving to a different board. Now you just have to go and you change these numbers here, and everything should work. We want to move this here, the LED pin. All right, so now they still won't do anything with the NeoPixels. For the NeoPixels, you'll have to call a routine called begin. And that can happen when you're ready to use them. We'll also just add a clear, so it's all set to 0. And then here, let's try, we're going to add pixel index, and we're going to set it to 0. And then we're going to turn 1 pixel on at a time. So here we'll say, is it set pixel? Pixels, set pixel. Where's it set pixel color? We can go back to the sketch here. I think it's set pixel color. So yeah, we'll just grab this line here. Pixel set pixel color. And we'll use this variable. So the difference here, the constant expression and variables is the variables are changeable, and this is hard coded. It's going to be immutable. So we'll set the pixel at pixel index, and we'll set it to, say, random 255, random 255. So actually we can make this a little bit more readable. Instead of doing it like this, we'll make a local variable and say auto. Red is this, auto green is that, and auto blue is that, and we'll just replace this with red, green, and blue. That's still going to be the first pixel with pixel 0. That's only changing every second. So we will increment the pixel. We'll say pixel index equal pixel index plus 1. And then we'll just check if pixel index is less than, it's greater than equal to num pixels. It's never really going to be greater than, but it's going to, if it's greater than equal, we're going to set it back to 0. So it's going to go in a circle. And finally, for NeoPixels, you'll have to say show. When you're ready, if you changed all the pixels you want to change, it has to be pushed to the board. So, and now it's just sort of random colors. Now, the other thing that now everything is happening on the same timer. There's always everything is 1 second, and that's not super exciting. So another sort of programming style that happens here is that people will set up separate timers. So let's see, last LED time, we set that to millis, and last servo time is millis, and last neo time is millis. So this is all going to initialize to the current time when the board starts up, and we'll set up, say, LED delay. We'll set that to 500. Servo delay we'll set to, say, 1,000, and NeoPixel delay we'll set to 100, for example. And we're going to have a toggle for LED, a toggle for servo. And here what we can do is we can start with, we get the current time as a variable. So we say now equals millis. And if now is less than, no, sorry, if last LED time is less than now, we are going to do the LED toggle. So we say toggle LED, and we'll do this here. So now instead of having a single variable called toggle, we'll have a toggle LED variable. And finally, we have to set the last LED time to the last operation we did. So set that to now. Same thing we do with last servo time is less than now. And then we'll do the servo, toggle servo. And again, do the same trick here. And set the last servo time to now. And finally, we'll do it for the NeoPixels. And there we're not using a toggle, we're just using the index. So we'll set the last Neo time. All right. Oh, I didn't. All right, I didn't actually put in a time. So the last LED time plus LED delay. Sorry. So you have to, you want to have it greater than 500 milliseconds, 1 second, and 100 milliseconds. So plus here, and I would say plus servo delay and plus Neo delay. It should be faster, isn't it? That's probably true. No, if the last Neo time is plus the timer is less than the now timer, it should be. Oh, I got to remove the delay probably. That probably helped. Still, only thing happened every 1 second. So the Arduino IDE is actually faster. So yeah, I mean the nice thing with this IDE is that you can mess around. You won't damage anything. It's not 100% representative of how the things behave. The NeoPixels, for example, are much brighter in real life. So when you're working with them, you kind of have to put something on top of them because it will start to hurt your eyes. But there's all sorts of things you can put in a push button. Say you can add a push button here if you want to. So we'll pull this one to ground, and is it left and right? I think it's this way. So I think this will go. So let's send this one to say to pin 7. So we can make it react to something. Say, and now we'll have to. Typically, you want to, with the pin that you're pulling to ground, you want to make sure it gets pulled up. So we'll add. I can explain that in a second. We'll add the pin number here. So button pin is what was it, 7, So we say button pin is input pull up. So what the pull up does is that when there's no activity on the line, it pulls it up to the voltage, right? So that that just sort of helps you avoid false positives when somebody presses a button. Otherwise, randomly, there's some delays in how the electronics react. You might get false presses without a pull up. Now, since we're running through the loop without any delays, we can just say digital read to read the button pin, and say if button pin is true, we're gonna actually maybe just change this. Instead of having we'll disable the LED toggling on and off, and we'll just turn it on if the button was pressed. We'll toggle it that way instead of just the timer. So we'll toggle it on and off by pressing the pin. Is it working? Nope. Not doing anything. That's probably because I didn't wire it properly. Let me see. One second. I think you can remove this pin here. How do I do that again? Yeah. So connect it this way instead. All right, so it works opposite now. So it's while it's we have to say if digital read is false, and we may have to debounce this anyway. So let's try this. Yeah. So now. Oh, it's because I changed the state each time. So, right. So as long as I hold down the button, it is working. We wanted it to toggle. And it's most likely we have to debounce it. So for a pin like a push pin like that, you will get a on and off reading. So what you do is you average out the readings if you're getting it consistently off or consistently on. Let's see. Was there anything in particular you guys were interested in hearing about? Any questions?
Has anyone ever done Droid inside here, the software, setting up in here? Show examples for people that are not.
Setting a droid up in the actual WoW wiki, is that what you're talking about?
Yeah, setting up everything the whole week for your average droid program.
So
Let's know if anyone's done it or not, make an example.
So there are some in the Real 2 library. There are some Wokwi playgrounds here where you can see, say, for example, the holo projectors. Let's go look at the holo projectors here. Is this text readable? It's kind of small, isn't it? I'm not sure I can make it slightly bigger. So this is using the Real 2 library where you can set up servos and holo projectors. This is based on sketches from the club. So for example, the holo projectors are based on the Fliffy code, but it's made into a library. So if you wanted a droid with 6 holo projectors, all you have to do is you have to add another, say, hollow light here, and give it a pin number. Now, if I run it, it's going to act like the hollow projector that's in the Droid.
I don't really know the programming very well.
Okay.
I love this tool right here.
Yeah.
You're going through the commands because you know them all, and learning for me to learn
Yeah.
which commands are used where and how it needs to be formatted.
How to write the code, you mean? Right. So, yeah, it's, there's multiple good resources out there on how to program in Arduino. What the Droid community mostly uses is Arduino, which is C++ actually underneath. But for the most part, the sketches try to keep it not too C++-y, which can keep it pretty complicated. What? Yeah. Right. But so there, yeah. So I'm not necessarily pushing the Real 2 library, but it is based on the sketches from the club, but made into a library to make it a little easier to reuse. For example, here's multiple servos, and let me see. Yeah, you press the buttons. Here are the buttons. It's doing like panels on the dome, but with like a flapping. A lot of people use the Maestro, so they can sort of just send a command to the Maestro to run a script, which they then tune by hand to instead of writing it as code. But in theory, you can take any sketch from the club and load it into here, add the library, and run it. You have to add the components. You have a fancier example here up on the Wokui website where it's running multiple servos, sort of dancing animation. Obviously, you couldn't power all that stuff from a single mega, but the code would be the same. So it's a great utility to mess with. It would be nicer if they had more type ahead, type completion. And they do, if you don't do it through the browser, you can install it into a tool called Visual Code at Wokui, and then it'll sort of help you type in, like, for example, the NeoPixel library, where you import the NeoPixel library. Now I don't know what the variable is, or the class is called the Adafruit NeoPixel. How is it spelled? Uppercase N, lowercase n? I don't remember. But you just sort of start typing Adafruit, and it starts to show you. And this does some type ahead, like here include. It shows me the include libraries, include header files that I can include, but it doesn't for the variables. So if I say servo, it doesn't show me that. But if you have the Visual Code, install Wokui into that, that's also a bit of a learning curve as well. But there's some resources out there for that as well.
So for people that are new to Arduino,
Mm-hmm.
can you explain why it's important to reduce or hopefully eliminate the use of delays in your routine?
Right. So you saw that earlier in our simpler example there, that if we just had delay, if we just had the delay here at the bottom, it prevented, say I put a delay here to 1000. Now everything happens every 1 second. It prevents all the other code from running at the same time. So, you might have parallel things going on. You have the servo moving at a different time than your LED, or the fact that you want to be able to read the button or the ring, but everything is now gated by this delay that's here. So it's a nicer style for that is to have set up sort of individual timers that you just check. Is it time for this now? Then you do this. If it's time for that, so it's not a state machine per se, but it's a little extra state. There are some cases where you have to have a delay of usually not as much as a millisecond. There's the U delay. Is it micro? U sleep, or I forget which one. There are some delays in hardware that are needed sometimes in microseconds, and that's usually not a big deal. Any other questions? No? Okay.
So you said your real two library?
Yeah.
The input in your life? You have to do it every time? Like,
Do you have to do what?
import the library every single time?
Right.
I mistakenly thought that I was stuck with just whatever was in it. Look, you can import your own library.
You can import your own libraries. I think you have to set up an account to do that. You can import any code you want. But I think they want you to have like because now if I am logged in here as an account, so you can go into the library manager, you can say add a new library and upload a library, and then you can go find one. Yes, you could upload any library. I mean, you could simulate a whole dome in here, but it might be overkill. It's usually better to focus on like a part, because there's some limited space to put in. If you start putting 13 servos, and it starts to get a little cluttered. Anything else?
You mentioned the club real two library. Where are those?
So they're usually sketches. Most people write them as a sketch. So like the Fliffy holo projector sketch is up on the website with that. The logic engine for the R series and for AstroPixels. Both of those now use the Real2 library, but they were previously sketches, and the Real2 library just sort of was evolved from code that was originally written for the logic engine by Paul, and there was another one, right? Yeah. It's all evolved code. There's credits in the code for at least the people that I know of, and there's no intention to actually steal from anybody. If we know that they need the credit, we try to credit everybody we can find. I mean, certainly much of it's based on Mark's code originally as well, for like the animations for the panels and stuff. That's all based on his code.
So how do you hook up the switch here?
Yeah.
How would you go about assigning it to a platinum?
Of a remote? Well, so there are different ways to read the remote. If you have an RC signal, some of them are PWM signals where you're just reading an input that's greater than this value or less than this value. Say if you have a switch on your receiver. For that, there's what is it, pulse input in the Arduino library that can read a single pin and return the value. So it will return the RC value, the pulse value, and you can then decide to react if it's greater than or less than a certain value. There are other ways. There's also the SBus protocol, and there are libraries up here that read SBus, which is just sort of a little packets of data in the RC signal. And then there's, of course, when you get to ESP chips, so you can have a Bluetooth packets that are sending you, and there are libraries as well for that. For example, the Shadow MD sketch uses the USB host library to read a Bluetooth dongle, which then can react to it. I'm not sure there's anything in the simulator here useful for that. I think the easiest way to simulate it here in the simulator would be putting push buttons to put in the reaction. We can see if there's anything. But I mean, it does simulate an ESP32. You can put it ESP32. And yeah, I don't know if that Bluetooth works in there though. I haven't tried that. They have infrared remote, infrared receiver. So that would be one way to do it. Set up a IR remote or a keypad. So there's a lot of little devices and sensors that you can play with, and they've been adding them. If you sign up for an account, I think you can pay them if you want to. Then you get a certain number of votes a month for features that you would like to see added. Yeah. Any other questions? No? All good. All right.